Hello everyone. Today we're going to discuss rates in real life. So far we have been emphasized the derivative as the slope of a line to a tangent line to the graph. So the interpretation is very visual, and usually when examine the graph of a function, we will continue to use it. So let's recall what is the rate in life. So the most common thing that we think about maybe is the most common rate that you've seen in math probably is the changing in y over the changing in x, which is the slope of a linear function. And later, as the more that we learn about math, the more that we know, hey, there is this is the constant rate. We also learn about average rate of change. We also learned about instantaneous rate of change. So the definition of instantaneous rate of change is going to be fs plus h minus fx over s plus h, that's the changing in x, minus x. So when you simplify it, I will have this. So that means if h approaching to 0, that means x and h is going to be, the 2 points are going to be very close. What happened? This is going to be the derivative at x, right? That's how we define derivative. So think about it. If the unit for x are the years and the unit for fx is our people, so fx is the units. Let's say represent the population of a people, and x is represent the year. Such as when you're trying to measure the countries, how many in certain amount of year, how many peoples, and then in next year how many peoples, and then the units for df over dy. What's that mean? This is the derivative. It's the rate of changing in population, right? You think about it, every year. So far before these classes, so far maybe you've learned the rate of change would be linear, right? But we know that in reality, this is not true. In reality, is each year the rate of the changing is different. So from now on, it's more accurate when we measure the rate of change, use derivative instead of just simply the average rate of change, right? Okay, like graphically, we can have the slope f prime of x is the slope of the tangent line, right? At the point x and fx. Okay, so another application of derivative is the velocity. So if you think about that, if fx is the position of an object at a certain time, then x represents the time, right? So what will be the f prime is? In that case, f prime is the velocity of the object at time x. Just like when you're driving, you will see the dashboard, your speed will change all the time. Maybe on average for me, it takes me 15 minutes to drive to school, and then the total distance is, let's say, 3 miles. So can I say that, hey, the distance, my average driving speed is 12 miles per hour? But this is not true when it comes to instantaneous, because the reason it takes me so long for 3 miles of driving could be, hey, there's multiple stop signs and there is a traffic jam due to heavy traffic in the morning. So that's why it's more accurate for us to describe velocity as the instantaneous speed. So f prime of x is equals to derivative of f with bet of x. Or think about it. The fx represents the distance, so the unit is going to be miles. And then the time usually measured by hours. You can do minutes. So as we describe the unit of the velocity, which is a prime, f prime should be mile per hour. Okay, so what other thing is very common for us to see is in the business world, like a marginal cost. So marginal cost and marginal revenue or marginal profit. We explore these terms in more depth in the later section. So basically, marginal cost is approximately the additional cost of making one more object once we have already made X amount of objects. So in the unit, for example, if I'm trying to make X bicycle, let's say X, let S be the amount of bicycle that the manufacturer are making, already made. And then Fx is the total cost of making S bicycle. Then f prime of x, which is equal to the derivative, the function at x, are what would be the unit? So the total cost would be the dollar, right? Over the bicycle, right? The amount of bicycle, 1 bicycle, 2 bicycle, so it should be the cost per bicycle. Okay. So in the business context, the word marginal usually means derivative or rate of change of some quantities. So now, since we already talked about business, since this is a business cal, so let's talk more about the terms of what terms for the business and economists, such as fixed costs. So we sometimes use FC for the short notice, for the short term for fixed costs. It's the amount of money you have to spend regardless how many items you produce. So fixed costs can include things like the rent, the purchase cost of some machinery, and the salary for office staff, and you have to pay the fixed cost even you don't produce anything. Okay, so the second term is the variable cost. Which is within. So the variable cost is for the numbers of items, the amount that, like variable costs such as you walk in for Starbucks, right? So the money that the Starbucks paying for you is considered variable cost. So if we work there for 3 hours, if the rate is $20, that means they have to pay you $60. So that's variable cost for Starbucks. And another thing would be commission-based salary. So that would be a variable cost for the company. And the other thing would be manufacturing. So the fixed cost probably is the rent, if your annual salary, that would be the annual salaries employees. But the variable cost could be if you're making something, the raw material you're trying to purchase to make that stuff is considered variable cost. So a variable cost would be the kill item. It's the amount of money you spend to actually produce them. So the total variable cost should include things like material that you use, electricity to run the machinery, the gas line for your delivery van, maybe the rate of your production workers. Those costs will be vary according to how many items that you produce. So the total cost should equals to the fixed cost plus the variable cost. Well, so another one is the average cost. So the average cost for Q item is the total cost divided by the quantity. Is the total cost divided by the quantity of stuff that you produce. Okay. So, and then the calculus part, marginal cost. So marginal cost, we will use the letter MC to represent that. So marginal cost at Q item is the cost of producing the next item. So that would be what? So the marginal cost at Q item should equals to the total cost should equals to the total cost when you're producing Q plus one item, subtract the total cost for you to produce Q items. So the difference between basically is the idea of produce one extra items from after you produce Q items. For example, the marginal cost of 100 bicycle, so should be the total cost of producing 110 bicycle, subtract the total cost of producing 100 bicycle. That would be the marginal cost. So in many cases though, it's easier to approximate the difference use calculus. So instead of marginal cost is easier to consider this is the derivative of the total cost. So why is that? Because in here, so how do you find the derivative? Remember? Let's try to prove that. How do you find the derivative of the total cost at Q items? Well, by the definition, should be the total cost Q plus H minus the total cost at Q item over H, the difference of quotient. That's how you define derivative. So if we let H equals to 1, consider 1 is the closest item, because when you're at the factory, in the early session, we talked about the closest should be 0.0001 negative or positive, or 0.0004, something like that. But in reality is, we can produce 0.001 item. The next smallest item that you can get should be 1, right? So if we let H equals 1, we will have the total cost Q plus 1 minus the total cost of Q, and then over H, which is 1. When you over H, that means everything is the same. Over 1, that means you should just get the numerator. Alright, so if you take a look at these, this is what? This is the definition of marginal cost. So this is also how we get the derivative of total cost at Q item. In that case, marginal cost can be defined as the derivative of total cost. All right. So let's take a look at these examples. So the table shows the total cost of producing Q items. And then what is the fixed cost? So what do you think the fixed cost? Well, if you're producing 0 item without producing anything, you're still paying the whatever, maybe rent or the workers for 20,000. So that means 20,000 is going to be your fixed cost. Okay, so now $20,000 should be your fixed cost. So when 200 items are made, what is the total variable cost? The average variable, and what is the average variable cost when you're making 200 items? So now let's take a look. When you're making 200 items, your total cost at 200 items is going to be 14,500, right? But that 14,500 including what? Well, including your fixed cost plus your variable cost, right? So the fixed cost from the previous question, we already found out that, hey, this is equal to 20,000, and your total cost is 14,500. So that means your variable cost should be your total cost subtract your fixed cost. So the variable cost in this case is going to be 25,000. And then they ask you, hey, what's the average variable cost? When it comes to average, you know that you are going to use the total number of something divided by the amount. So total number of what thing? Since they ask you the average of variable cost, so you want to know the total variable cost, not the total cost, because they just want to know the average variable cost. So you need to use the total variable cost to divide the amount. So the total variable cost should be 25,000, and then the amount we divide by 200. So I got $125 per item. be careful about the unit. So that means what? So on average, each item had a variable cost of $125 if you're making 200 items. Okay, so number 3 is when 200 items are made, estimate the marginal cost. Well, to estimate the value of derivative at 200, or the slope of the tangent line at when the quantity equals to 200, well, we need to find the secant from, so we need a secant from when you're making 100 products to 200 products. Why is that? So let me give you a graph to show you why we need to do all this secant line stuff. So here, $20,000, $14,000, and then $16,000, and then when you're making what? 100, 200, 300. At 100, at 0, your fixed cost is 20,000. At 100, your cost would be 13.5. 200 would be 14.5. Up here. 300 would be 55. So your graph is look like this. It's a curving graph. So if we can find the secant line in between these 2 points, that will give you an idea about, hey, this is the closest number we can get, because we don't know 201, right? The closest number we know is given is 100. And also, when you're finding a tangent line, you're not just looking for the point close to the destination point 200 that we want on the left side. We also want to find some point on the right side, which means we also want to find the secant line. Oops. From Q equals to 200 to 300, right? So what we can do is, after finding these 2 secant lines, we take the average as the slope of the tangent line at x equals to 200. All right, so let's do the first approach. The first approach is we want to find the secant line from Q equals to 100 to Q equals to 200. That would be the first slope that we are trying to find. So the first slope, m equals to the changing in y over the changing in x. When you're producing 200 items, your cost is 14,500 minus the cost when you're producing 100 items, which is 13,500 divided by 200 minus 100. So the slope for the red line is going to be 100. So I'm going to mark it here. All right, so now the next step is you also want to find the secant line from Q equals to 200 to Q equals to 300. So when Q equals to 300, we have 15,300 minus 14,500 over 300 minus 200. So this gives you 80. So we could estimate the tangent slope by averaging this secant slope, giving us the estimate of what? Well, so the estimate tangent line slope should be 100 at 80 divided by 2, which is 90. So this tells us that after 200 items have been made, it will cost about $19 to make one more items. Because you remember the rate represent what? The rate. The rate. Oh my god. Okay, the rate is going to equals to the unit of the rate would be USD per item, right? USD per item. So remember that this tangent line is what? Is the marginal cost. How do we define the marginal cost? By definition, marginal cost is after you made Q items, the cost of making an extra items. So the slope is our derivative, which is the marginal cost at 200 items. So to explain this should be after 200 items have been made, it will cost $19 to make another one. Okay, that's one example. All right, so now let's talk about more terms. So in business world, you also have a demand. So demand is the function relationship between the price and the quantity. Q, it can how many stuff you can be sold depending on your situation. So demand is the relationship between the price and the numbers of items, the amount of items that produced. Also, we have revenue. Revenue is what? Revenue should be the price for each item, the unit price, times the quantity that you sold. That would be your revenue. So total revenue is the Q items is the total amount of money you take in for selling Q items. It's the total money that you take in after selling Q items. Okay, and then you have the average revenue, which is how much does it cost, how much money you're going to sell for Q item. Basically, is the price. Okay, and then you also have a marginal revenue. So how to get marginal revenue? So it's the same definition when it comes to marginal. So the marginal revenue is at Q items is cost producing is, I should say, the revenue of should be, I should say that the marginal revenue should be the revenue when you produce one more items after you produce Q items, or after you produce or sell Q items. So it should be the total revenue of Q item Q plus 1 item subtract the total revenue of Q items. So this is going to be your marginal revenue at Q items. Also, you can interpret this as what? The derivative at total revenue at Q items. Okay, so your profit, so what is profit? So the profit should equals to your total revenue. Total profit should equals to total revenue subtract the total cost. But for each items, like early example we have here, because the producing cost is a curved line, so maybe your total revenue is also total profit or total revenue also is going to be a curved line. But remember that the profit is the differences between the revenue and the cost. So for example, if I give you a graph at here, so let's say the total revenue, the total cost, I'm going to use a red pen to represent, would be something like that. This is a total cost. So how do you interpret this line? Well, at this point, when you don't have any number of items, let's say this is the quantity of the merchandise that you produce, the number of the stuff that you cost, this is how much you pay for that. So at this point, this is what? Your fixed cost. So that means even though you produce nothing, you still need to pay this amount of money, right? And then the fixed cost slow down. As you can see, the slope getting slower and slower, right? Why is that? Because maybe that makes sense. The more that you produce, probably you save more money since you even out the fixed cost. But at some turning point or inflection point, which is they're going up, but the concave, from concave down to concave up, what do you think? What caused the changing getting more steeper? Well, probably when you reach this point, you need another machine to help you out. So that means your fixed cost is going to increase, which makes your total cost is going to increase, right? So maybe that's the problem, or maybe because you require the worker to work overtime. By law, if you work overtime, you need to pay, I think it's 1.5 times of their salary. So maybe that increased the variable cost, any reason. So anyway, so that's why it's going steeper and steeper. Whereas if I have another graph look like this way, and I tell you that, hey, this is going to be your total revenue. So how do you interpret this? Well, total revenue has to start with 0, right? If you don't sell anything, the number of items that you sell is 0, you are not going to get in any revenue. So as you can see, for revenue, it makes sense. The more item that you produce, the more money that you're going to get. It's always increasing, but it will slowing down. Well, maybe because the more item you produce, you're starting to have some overstocking problem, and because your total cost increase, remember revenue is equals to the total cost is increased, so that's why maybe the revenue is slowing down because the cost, unless you increase the price of items. Okay, so what is the profit? Well, by the definition, we know that the profit equals to the revenue minus the cost. So in here should be what? This is your profit. This is going to be negative, right? Because you don't make enough money to cover the cost. However, after that turning point, this is going to be your profit, a positive profit, right? Because you make more than the cost, and then when you reach some threshold, it's going to change. So that's how you read this graph. So there's another example about the rate or derivative in real life. So here's one. The length of the daylight time in Seattle is a function of the day in the year. For example, on August 12th, 2012, there was about 14 hours, 24 minutes of daylight. In Seattle, August is the summer. And then after that, when you pass August, your daylight time is going to decrease, right? So the derivative of this function is about minus 3 minutes per day on January, where when you start in the winter time, there was about 8 hours of 52 minutes of daylight, and the derivative was about a positive 2 minus a positive number, which is 2 minutes per day. So the length of the day was increasing by about 2 minutes a day. So on the graph, what do you think these look like? So if we're starting, our starting point is August the 12th. And then at here, let's say January the 15th. And now a whole year, this is August 12th. So this is hours. How many daylights in hour? In August, maybe you reach the peak, which is 14 hours, 24 minutes. This is 14 hours, 24 minutes. And then as the time goes by, you decrease to the amount of what? 8 hours and 52 minutes on January the 15th. And then after you pass January 15th, you're going back up because you're increasing the daylight time. Well, when you're doing the derivative of this change before January the 15th, your change is going to be what? A negative number because you're decreasing the number. So the rate should be negative 3 minutes. So that would be the slope of the tangent line. 3 minutes per day. Whereas after you pass January, after done with the winter, your rate is going to increase, which is you're going to have your daylight time increase 2 minutes a day. Okay, so this is some application of race in our real life. Let me know if you have any questions.